So we want to review this a little bit here. So the UTF-8, right? We said since most applications need only the ASCII character set, it is a waste to represent an 8-bit ASCII character as a 16-bit Unicode characters. The UTF-8 is an alternative scheme that stores a character using 1, 2, or 3 bytes. ASCII values less than 0x7F are coded in 1 byte. Unicode value less than 0x7FF are coded in 2 bytes. Other Unicode values are coded in 3 bytes. So UTF is going to support those. ASCII, Unicode with 2 bytes, and Unicode with 3 bytes. So what's Unicode? What's UTF, right? So, and what's ASCII? So let's look at this basic first. What is ASCII? ASCII stands for American Standard Code for Information Interchange. Okay, so you may see there's an Ascii table right here to represent a death rate, so that the characters like that we type and communicate through the keyboards or any input devices. So those are the codes, and you see it's about 255 of them, which is, if you set 8 bits, can represent 255 values. So ASCII is about 8 bits. Okay. I mean, it's using 8 bits to represent the data. Now, if you look at Unicode, now let's talk about Unicode. So it's a computing industry standard for consistent encoding representation. Encoding, like ASCII, is encoding the characters into the binary numbers, which is the machine code. Same Unicode is the same principle here. And handling of text expressed in most of the world's writing systems. So that's the difference, is the world's here. ASCII doesn't represent the international alphabets. So, but if you look at Unicode worlds, that mean they do, right? They do represent the any world's language alphabets, right? Let's see an example. So those are the special international alphabets for Malayalam, right? Language. We can look at the Arabics, right? So those are Arabics. So that's why we need Unicode. ASCII is not enough if you want to make an application to support international or multi-language, right? And Unicode has Unicode 16, which is 16 bits. We have UTF-8, which is 8 bits. UTF-16 is 16 bits. 16 bits, 2 bytes. Because in order to support those characters, you need a longer bits. Let's look at an example. We can support the symbols too. This is like, maybe look like Greeks, Roman, in the Egyptians, right? Anatolian hieroglyphs. And you see each digit represents 4 bits. This is hexadecimal numbers. There are 4 digits, so this is 4 is 16 bits. It looks like this is even more than that, like 5 digits, right? 1, 2, 3, 4, 5. So that's going to be 5 times 4 is 20 bits. So let's see. Let me find something like loud. So this is 4 bits, right? So I'm talking about this one like 16. I mean 4 digits for hexadecimal. Then 4 times 4 is 16 bits to represent this for Laos language alphabets. Alright, so now we see these are the Unicode, right? And Unicode can have like up more than 8. That's why the slide said more than 8 bits, so it's come to 16. So 8 bits is 1 byte, 2 bytes 16, and it could be more than that, right? Like we just see that some like international alphabets we need 20 bits, so that 3 bytes. 3 bytes is 3 times 8, 24 bits, so that should be enough, right, to support. Like we always do like double by 8, 8, 16, and 24, right? So UTF pretty much just support all of this, so that's why it's become something very, very popular. So if you look at the chart here, right, you may see UTF-8 is a character encoding capable of encoding all possible characters, all code points, like ASCII, UTF-16, this is Unicode, and UTF-32, which is this is also Unicode for 4 bits. 4 bytes, I mean, right? 8 times 4. 8 times 4, right? It's bytes. 8 times 4 is 32. So that's why it started in about late 2006 or 2007, early, and becomes very popular until now. And ASCII encoding and also start to be obsolete, according to the graph here. So we like to use UTF. So using data input stream, data output stream. So we're learning about writing a data right into a binary file. So that's why we have to understand the standard here. UTF is a standard. Right. Now, when you read and write, you pretty much don't worry about how you encode or decoding it. We talk about standard UTF, which is used to encode and decode, right, your characters. But writing and data stream or reading a computer, actually they only worry about the binary code, which is 0110. They don't care. But the problem is we have to decode it, then human can read it, because application used for human. So when you read and write, we pretty much just use the data streams, right? Use the wrappers or existing input and output streams to filter data into original stream. They are created using the following constructors. So for input stream, you use the data input stream and pass in input stream. Data output stream for output. Statements given below create data streams. The first statement creates an input stream for in.dat. So that's the data file name, which is in the binary format. And the second one do the output stream, out.dat. So for the file stream, we can use file input stream and file output stream. we can look at the program here. So data output stream, new file output stream, and we can use write UTF. So we can write as UTF format. Write double, write UTF gem, write double. So pretty much we convert this statement to UTF standard and convert that into the binary file and store it like a stream of 01 and 10 onto temp.dat. And if you want to read them in, do the same. We have to read the UTF and read up double from the same file. When you read, you just do the data input stream and pass the file input stream with the file name. So once we run and compile, we should be able to write, which is successful writing, and read back the data which we wrote into the temp.dat path and print out to the console here. So that's how we write the data into the binary file and read it back using the data output stream and UTF standard to do encode and decode. Order and format. You have to read the data in the same order and same format in which they are stored. Like we see that we store string first as UTF. We have to read UTF string first. You can't do like read double first, right? And then we read double and then we write UTF. We have to read UTF and read double in the same order when you start to store them. Since names are written in UTF using write UTF, you must read name using read UTF. And how to check the end of file. So we can use, if you keep reading data at the end of a stream, and end of file exception would occur. So you can use input.available to check it. If it's equal to 0, indicates that it is the end of a file. Right? If you do iterations, you don't have to keep doing this. You can just create a loop, right? You don't have to write this 3 times by checking in the end of files using input.available. Now, the next topic we're looking at is we want to look at buffered input stream and buffered output stream. So buffered input stream, buffered output stream does not contain new methods. All the methods buffer input stream and buffer output stream are inherited from input stream and output stream classes. So what is the pipeline concept here? So we have data input stream, which is going to have it into int, double, and string. Right? When we use the input stream, data input stream, we're going to rely on file input stream, which is in the format of 011001, the binary files, getting from the actual external file itself. Same output stream, we just take the input double string type and encode it into 010101, which is file output stream, and put into external file temp.dat. Now constructing buffered input stream, buffered output stream. So create a buffer input stream, we can do buffer input stream and input stream in. Right, input stream. We talk about input stream here, right?